Dear students, welcome to EPG Pathshala. Today in this module, we will be discussing about landfill bioreactors. Now let's look into the learning objectives of this module. The learning objectives of this module include to understand the concept of landfill bioreactor, to know the different types of landfill bioreactors which are available, and also to study the factors influencing the waste degradation in landfill bioreactor. Then we will realize the various advantages and disadvantages of landfill bioreactor. Finally, we will conclude this module by studying the various monitoring parameters of landfill bioreactor. Now, let us brush through the introduction which I have already told you. The disposal is a final step in the management of solid waste. Most of the developing and underdeveloped countries, they dispose of or they dump their solid waste in an open land without any protection or environmental control. They are disposed of into water bodies or just burnt in open areas, which is generally termed as open burning. The developed countries are practicing a system of safe or controlled dumping called as the landfilling. Now, as I told you, landfill is an engineered structure where the waste is safely disposed or contained to avoid environmental and health effects. They are usually made up of cells where discrete volume of waste is kept in isolation from each cell. What I mean to say is the landfill is divided into imaginary cells where the waste is loaded and separated from the adjacent cells by a suitable barrier. Now, a liner system is provided at the bottom and the sides and on the cover which will be acting like a geological barrier. The requirement and type of the barrier system will depend upon the nature of waste that is being loaded. Now, the liner materials, both natural as well as synthetic materials, are used as barriers. The landfills are generally composed of three main components. One, the liner system, which will provide protection at the bottom and it will protect the soil and the water. Then comes your waste emplacement cells, that is the pattern by which waste is loaded into a landfill cover or by which the waste is loaded into the landfill. The third one is the cover or capping, which is the topmost protection layer that prevents the entry of water or other animals into the waste pile. This figure shows the structure of a conventional landfills. Generally, landfills are designed for the purpose of safe disposal and environmental protection. Though you provide or you take steps to control the leachate or the gas collection system, still they fail and they cause environmental damage. Moreover, the rate of waste degradation inside the landfills are very slow. It takes many years for its degradation, or it takes many decades for degradation. Also, the gas generation is very slow. Thus, the concept of landfill bioreactors came into existence, or it was developed with a purpose to accelerate the rate of waste degradation with simultaneous environmental protection. So, a landfill bioreactor is an engineered landfill developed to speed up the process of waste degradation and promote environmental protection through proper gas and leachate management system. Waste stabilization occurs within 5 to 10 years of implementation, but it requires a minimum of 35 to 40% moisture to increase the rate of waste degradation. At times when leachate is not sufficient enough to maintain the required moisture content within the landfill bioreactor, then you can opt for other liquids like the storm water runoff, wastewater treatment sludges, etc. The efficiency of a landfill bioreactor is also increased by other factors. Shredding will improve the degradation and it will accelerate the rate of degradation. Also, you can add nutrients through the incoming waste stream, either through other modes of maintaining moisture. You can add through that. You can adjust the pH, and waste pre-disposal and post-disposal conditioning and temperature control will also act as a factor to accelerate the rate of degradation within a landfill bioreactor. Landfill bioreactors are of three types. If you see, they are classified based on the working mechanism as aerobic, anaerobic and a hybrid landfill bioreactor. In an anaerobic landfill bioreactor, waste generally undergoes aerobic degradation. Air is supplied into the system through vertical and horizontal tubes or wells to facilitate aerobic degradation. The leachate that is generated during decomposition will be collected and recirculated with other liquids. This generally helps in maintaining the moisture level and thereby it will accelerate the degradation efficiency. Also, it will maintain the microbial inoculum within the waste mixture and it will stabilize the waste. Some amount of air also enters through leachate circulation, thereby accelerating the aerobic degradation. The process of waste degradation is very fast in aerobic bioreactor landfills. So, in this image you can see the aerobic landfill bioreactors, where you can see a lot of tubes through which air is passed through to facilitate aerobic degradation. The second type of landfill bioreactor is an anaerobic landfill bioreactor. The waste in the anaerobic landfill bioreactor generally undergoes anaerobic decomposition and results in the production of gases such as methane and carbon dioxide. They are generally referred as landfill gases or LFGs. In anaerobic landfill bioreactor, the gases are recovered and can be converted or used in the form of energy. Greenhouse gas emissions are also minimized during the operation of anaerobic landfill bioreactor. The leachate generated from the anaerobic LFBR is collected and recirculated to maintain the moisture level within the system. As I told you earlier, 35 to 40% of moisture is generally required to accelerate or fasten up the degradation of waste. The leachate generated during the process is not sufficient to maintain the moisture within the LFBR in an anaerobic landfill bioreactor. In that case, you can use either sewage sludge or non-hazardous liquids or any storm water for maintaining the moisture within the bioreactor. The appropriate moisture generally increases the efficiency of waste degradation and it also densifies the waste. The gas generation becomes double than the normal landfill. The rate of gas production is also very fast. The advantage of an anaerobic landfill is that they can also handle peak waste flows due to accelerated gas production within a short period of time. The third type of landfill bioreactor is a hybrid landfill bioreactor. In a hybrid landfill bioreactor, it is generally designed in a way so that both aerobic and anaerobic degradation occurs within the reactor. The operational simplicity of anaerobic process and efficient degradation of the aerobic system is combined in this landfill bioreactor. It is generally known as a aerobic anaerobic bioreactor landfills. The upper portion of the bioreactor will be generally operated in the aerobic condition since it is exposed to the outer atmosphere, where the air will also be injected into the waste. The aerobic condition will facilitate faster decomposition and the bottom layer of the bioreactor is maintained in the absence of oxygen. The purpose is to attain faster degradation with simultaneous recovery of energy at the lower portions of the bioreactor. Faster degradation also reduces the production of organic acids and also favor faster onset of methanogenic phase. Hybrid landfill bioreactors are designed to combine the advantage of both aerobic as well as anaerobic landfill bioreactors. The operational simplicity of aerobic process and the efficiency of anaerobic process are both combined in the hybrid bioreactors. The next type of landfill bioreactor is a facultative landfill bioreactor, which is specially developed to control high ammonia levels in the landfill bioreactors. High ammonia concentration develops due to the leachate recirculation within the landfill bioreactor. The leachate that is containing ammonia is generally treated by biological nitrification process and the nitrified effluent is generally introduced into the anaerobic LFBR. Under anaerobic condition, the facultative anaerobes uses nitrates as an oxygen source and will then reduce it to molecular nitrogen by the process of denitrification. By this way, the molecular nitrogen is generated and molecular nitrogen is generally considered as safe and it does not cause any harm to the environment. Like other landfill bioreactors, the moisture of facultative bioreactor should also be maintained to achieve increased degradation. Now, let us discuss about the various components of a landfill bioreactor. Now, this image will show you what are the components of landfill bioreactor. It starts with the liner system, leachate collection system, gas collection system, daily and final cover at the top of the landfill, environmental monitoring system and closure and post-closure monitoring. Now, let us discuss about the liner system. The liner system should be placed at the base and sides of the landfill. Liners are natural or synthetic polymers and they can be used to protect the soil and groundwater present underneath. As I told you, liners should possess certain characteristics like they should be very strong, impermeable in nature, flexible, high tensile strength, they should be tolerant to temperature fluctuations and they should be UV resistant. The liners should be easy to install, they should be cheap and resistant to scratch and other chemical degradation. Because leachate contains a lot of chemicals within them, chemicals and suspended solids, hazardous material which will tend to affect the liner system. So, it should be chemically resistant. The common liners used in the leachate management are geomembranes, geosynthetic clay liners, geotextiles, geogrids, geonets and geocomposites. When you talk about the leachate collection system, it is a drainage system which is generally used to collect and transport leachate which is collected inside the liner. It is designed in a way so that maximum leachate is collected. The pipes of the drainage system are generally located at the bottom of each cell. The pipeline network should be flexible or rigid, but the joints connect these pipes should always be flexible to withhold the enormous amount of weight and pressure created by the waste that is loaded on top of the leachate collection system. The size of the pipes is larger than the conventional landfills. The pipes will get clogged due to the deposition of suspended materials. So, it has to be frequently observed if any clogging is taking place. The collection pipe network drains, collects, transports the leachate through the drainage layer to a collection sump where it is separated and for treatment or disposal. Now, after recirculation, the excess water must be removed from the bioreactor to maintain at least 30 centimeter or more hydraulic head. If not, the leachate leaks out of the system. The leachate collection system is generally classified as 5 different types and the table provides a leachate distribution system. For pre-wetting the waste, you can use a fire hose from water tankers or manual spraying can be done. It is generally a labor intensive process. The second method for leachate spraying, you can use a sprinkler. For surface ponds, you can use surface infiltration ponds above lift of solid waste. The fourth one is vertical injection wells where you use pumping or gravity force, which is a popular method. The fifth one is a horizontal subsurface introduction where again you use pumping or gravity force. Now, there are a lot of factors which affects or influences the leachate distribution system like climatic factors, worker exposure, evaporation loss, reliability, uniformity and aesthetics. All these factors help in determining the leachate collection system. Now, let us discuss about the gas collection system. An ideal gas collection system consists of a sequence of gas collection wells which are positioned throughout the landfill. The gas collection wells will be designed based on their volume and density of waste, depth and area of landfill. Collection wells in the landfill offer pathways for the passage of gas. The gas collection system is very important because if they do not work properly, then there is a tendency that an explosion can occur within the bioreactor. And you can also see more amount of gas generation in the early phase of operation. Moreover, when compared to the conventional landfills, the landfill bioreactors generates a high amount of gas. Now, next component is a daily and final cover at the top of the landfill. Now, cover protects the entry of water into the waste during precipitation. The cover layer is composed of synthetic and natural materials. Daily cover is done like 150 mm of soil is placed on each layer of waste. The cover, in addition to preventing the leachate from escaping through the sides of landfill, it also protects safety from other diseases, vectors, fire, odor, blowing litter, scavenging and contamination of the environment. Now, agricultural waste, sludge, worn out geotextiles and compost are alternatives that can be used as a covering material. They also will degrade along with the waste material. The next one is a surface water drainage system. These systems are established generally to avoid water accumulation in the surface of the landfill. It acts like a channel where the surface runoff is generally collected during precipitation. The landfill bioreactor should be continuously monitored, which gives the significance of an environmental monitoring system. The component helps in assessing the leachate or gas leakage, if any, during the environmental contamination. That means, if you continuously keep monitoring any gas leakage, or if you continuously keep assessing the leachate with the characteristics, you can judge what is the process that is happening inside the landfill bioreactor. The last one is closure and post closure monitoring. Let us look into the various process that takes place during the waste degradation within a landfill bioreactor. We have discussed about this in the previous module also, where I told you like different steps takes place in waste degradation within the landfill, starting from hydrolysis, aerobic degradation, then again hydrolysis and fermentation takes place, then acetogenesis followed by methanogenesis, and final oxidation takes place. The flow chart will give you what are the different process that takes place inside the landfill bioreactor for waste degradation, and the different products that are produced at the end of each phase. Like if you see for hydrolysis or during aerobic degradation, you can observe carbon dioxide and water that is being produced, and in hydrolysis and fermentation you can find organic acids and ammoniacal nitrogen. In acetogenesis you have acetic acid, hydrogen and carbon dioxide generation, and in methanogenesis you have methane and carbon dioxide generation, and finally in oxidation phase you have CO2 generation. So, these are the 5 stages of or 5 phases of degradation of waste within a landfill bioreactor. Generally the waste inside the landfill bioreactor, it undergoes physical, chemical and biological changes. Due to these changes, the waste gets even compacted and the volume of waste also gets reduced. In addition to these process, the biological process, I mean the different phases which I have discussed, all these things occur in the landfill bioreactor. Now, this table will provides a summary of what are the conditions that should be maintained for a better degradation within a landfill bioreactor. If you see, the moisture should be maintained like 60% and above, moisture content should be there. Oxygen should be having, it should have an optimum redox potential of around -100 to -300 millivolts, and this is favorable for the growth of methanogens. pH should be in the range of 6 to 8. Alkalinity, especially if you talk about methanogenesis, it is around 2000 milligram per liter, and the maximum organic acid concentration during methanogenesis is 3000 milligram per liter. And if you talk about temperature, the optimum temperature especially for methanogenesis is 40 degrees Celsius. Hydrogen should have a partial hydrogen pressure of around less than 10.6 atmosphere for acetogenesis. You should have adequate nutrients, sulfate salts should be there because sulfate salts generally decrease during the process of methanogenesis. So, an optimum sulfate salts should be there to accelerate the process. Certain inhibitors are there which should be avoided if you have to, if you expect a proper waste degradation in the landfill bioreactor. They can be ammonia, sodium, potassium, calcium, magnesium and other heavy metals. Now, this figure will shows you the gas generation during the 5 different phases which we discussed earlier. So, here you can see initially the oxygen drops down and slowly the carbon dioxide keeps increasing from phase 1 and it reaches a peak at the end of phase 2 and slowly it starts decreasing in phase 3 and 4 and completely drops at phase 5. And methane gas, it starts at the end of phase 2 and it increases, peaks out and it becomes stable in phase 4 and then drops at the end of phase 4. N2 molecular nitrogen, again it starts decreasing from phase 1 and then at the end of phase 3 it completely evades out, and then again N2 formation occurs at the end of phase 4 and it increases in phase 5. And in between, if you see, hydrogen also, it starts at the end of phase 2 and it peaks out at the end of phase 2 and then decreases in the phase 3. Now, let us discuss about the various monitoring parameters to facilitate faster waste degradation in the landfill bioreactor. The different parameters or monitoring parameters are moisture, temperature, gas flow quality, waste density and settlement, leachate yield and quantity, quality and leachate flux. A continuous monitoring should be done for the landfill bioreactors so that the operational failures can be minimized. So, leachate flux. The rate of leachate generation is very, very important because this is what is going to be used as a source to maintain the moisture inside the landfill. So, leachate circulation, recirculation should be continuously monitored and the moisture levels within the bioreactor should be continuously maintained. Also, you should be careful to avoid excess moisture because it will reduce the degradation efficiency and gas production rate. Now, next parameter is temperature. You should continuously monitor the temperature within the landfill bioreactor because they will indicate the stage of biological activity within the bioreactor. Temperature monitoring is very essential, especially if you talk about the aerobic landfill bioreactors because to avoid fires, sometimes it will help in catching fire. Then moisture, as I mentioned earlier, moisture is again an important parameter because without moisture you cannot fasten up the process of degradation. Also the microbial inoculum, bacterial growth, everything depends upon the moisture. So, continuous recirculation is done to maintain the moisture. Then comes the cellulose and lignin level. You have to measure the cellulose and lignin level in the bioreactor, which will facilitate in determining the phase of biological activity. Then the leachate yield and quality will again tell you what is the rate of degradation that is occurring inside the landfill bioreactor. Short circuits in the leachate system can also be determined. Then by characterizing the leachate, you can analyze what is the phase that is occurring inside the landfill bioreactor. Like the acetogenic leachate will have a different characteristic and the methanogenic leachate will have a different characteristic. Then you have to continuously monitor the waste density and settlement. The rate of degradation waste saturation is determined from waste density monitoring. Monitoring of settlement in the surface of landfill bioreactor might help in calculating the available space in each cell of the landfill bioreactor. This will also facilitate more loading of waste. Then you should continuously monitor gas flow and quality because when you analyze the quality and quantity of gas generation, that will again indicate the biological activity that is going inside the landfill bioreactor, and also this information will be required for expansion of the plan and modification of gas management systems. Now, let us look into the advantages and disadvantages of a landfill bioreactor. The rate of degradation, since it is faster in a landfill bioreactor than a conventional landfill, that becomes a major advantage. The waste within the landfill bioreactor shows rapid settlement and stabilization. The impact on the ground and the surface water is very, very minimum, and they generate a very high quantity of gas which is in a short period of time, which is again a major advantage of landfill bioreactor. The greenhouse gas emissions are generally reduced, which is again one of the major advantage of a landfill bioreactor. The leachate recirculation minimizes the cost involved in leachate treatment, and recirculation also avoids the entry of pollutants into the environment during leachate discharge. The residue left after degradation can be, you do not have to provide extra treatment to manage them. They can be used as a compost. The inert materials are generally removed periodically through landfill mining, and hence more space availability will be there. That is again an added advantage. After closure of landfill bioreactors, the land can be reused for other purpose also. Faster waste degradation is attained inside landfill bioreactor, and hence it avoids the requirement of a large area of land. Thereby the cost is also reduced when you use a landfill bioreactor. Long term environmental risks are avoided due to minimum leachate migration and recovery of landfill gas and controlled waste settlement. Now, what are the drawbacks of the landfill bioreactors? The cost of construction is too high as it involves many engineering aspects. You need a numerous network of pipes for proper leachate and gas collection, which needs to be established properly. Since it involves a lot of waste collection pipes, the cost of construction actually increases, and you require a skilled labor for the operation of LFBR, I mean the landfill bioreactor. The temperature control is very important because without that, as I told you, it will catch fire in an aerobic bioreactor. The other drawbacks include the geotechnical stability, odor control, liner chemical compatibility, availability of other liquids for storm water. Like for example, if the leachate generation is very less, you have to depend on other sources of liquids like storm water, sewage sludge, hazardous waste, etc. To summarize, at the end of this module, we have discussed about the concept of landfill, what is its significance, and what are the drawbacks due to which the landfill bioreactor concept was developed. Then we discussed about the landfill bioreactor, their components, their types, and then we also discussed about the various process of waste degradation within the landfill. Then we discussed about what are the different monitoring parameters which you have to maintain if you have to keep the landfill bioreactor working and fasten up the waste degradation. Then lastly, we discussed about the various advantages and drawbacks of landfill bioreactor. I am sure this module would have been of great help to you. Thank you.